Good morning, all of you. Today I'm Sakshi, a student of BSc Chemistry Honors, second year student. Today I'm here to represent my presentation on the topic of alcohol. Alcohol are generally characterized by presence of one or more hydroxyl group present on the carbon atom in an alkyl chain. Alcohol can be called as organic derivative of water, in which one of the hydrogen is replaced by alkyl chain, which is represented by R in organic structures. Alcohol are the most common organic compounds. They are used in sweeteners and in perfumes, and also used as intermediate in the synthesis of various compounds. Perhaps the two best known alcohols are ethanol and methanol. Ethanol is used in toiletries, pharmaceutical companies, fuels, and it is also used to sterilize hospital instruments. The anesthetic ether is also prepared from ethanol. Alcohol are also used in the preparation of alcoholic beverages. Methanol is used as a solvent as a raw material in the synthesis of formaldehyde resins, and it is also used in cleaning the metals, and it is also used as an antifreeze in the which is used in the vehicles. Alcohols are classified into primary, secondary, and tertiary alcohols. The hydroxyl group attached to primary carbon atom is known as primary alcohols. The hydroxyl group attached to secondary carbon atom are known as secondary alcohols. The hydroxyl group present on the tertiary carbon atom is known as tertiary alcohols. According to IPSC, in the nomenclature of alcohols, firstly we have to select the longest chain present in that compound, and then we have to number that chain from where the hydroxyl group gets the lowest number, and then we have to also name the substituents present on that chain, such as methyl or other functional groups which are attached in that particular chain. Thank you.
Good morning, everyone. I am Deepika from BSc Chemistry Honors second year. My presentation is on topic ether. Ether, the compounds in which oxygen functional group is present in the structure are called ethers. So here are some example of ethers. CH3O CH3. CH3 is here principal chain, and OCH3 it is substituent. Ethers are of two types: acyclic ether and cyclic ethers. Acyclic ether वो होते हैं, these are those ethers in which O functional group is not present in the ring, and cyclic ethers are those in which O oxygen functional group is present in the ring. For example, it is the example of acyclic ethers. The name of this is methoxymethane. And the example of CH3 is of cyclic ethers is 1,2-epoxy ether या फिर इथेन. Cyclic ether. We can prepare acyclic ethers in following ways: by Williamson synthesis. We will take CH3, CH2, OH, ethanol, and here NaOH as reagent. We will remove our Na as electron and Na positive. So we will remove from here H2O minus H2O, and here is our reagent CH3CHO Na, and Na is positive. Now we will apply Williamson synthesis in it, in which CH3CH2 OH. So we will remove OH2O. CH3CH2O, CH3CH2, CH2CH3. It is our ethoxy ethane. It is our first preparation. We can also prepare cyclic acids by another way. For example, CH3CH2Cl. We will take chloroethane. And here we will use at 413 Kelvin temperature and CH3CH2 OH. And we will remove our HC minus HCl. And we will get OCH2 CH3 ethoxy ethane. Our third method is CH3CH2 Cl chloroethane. CH3CH2Cl. And here we will take dry Az2 and it will remove minus 2 AgCl, this Cl and 2 Ag, and it will attach with this. First try Ag2. And ethoxyethane will be prepared and its physical properties. Properties of ether. Due to presence of weak van der Waals bond, it will have low viscosity, low boiling point, and it has no low soluble substitutes. Okay.
My name is Sonia from BSc Chemistry Honors second years.
थोड़ी तेज बोलो बेटा.
Today my topic on alcohols and its classification. Alcohols, the species which are formed by replacement of by hydrogen atoms from the aromatic and aliphatic compounds by the hydroxy group is called alcohols. For example. For example. Yes.
थोड़ी तेज बोलो बेटा, आवाज जानी चाहिए.
Methane. इसमें 7 hydrogen atoms by replacement by hydroxy group CH3OH. Methane. Its classification. Different way of classification. First way of classification. Aromatic alcohols. The alcohols which are formed by replacement of hydrogen atoms from the carbon chain by hydroxy group. For example, Number 2, aliphatic. The alcohols which are formed by replacement of hydrogen atom from the side chain of benzene ring by hydroxy group. For example, toluene, in second way of classification. Monohydric alcohol. The alcohols which contain one hydrogen atom. One hydroxy group. For example, CH3, CH2OH. Number 2, dihydric alcohols. The alcohols which contain two hydroxy group. For example, CH3, ethane 1,2-diol. Number 3, trihydric alcohol. Alcohols which contain three hydroxy group. For example, CH3, propane 1,2,3-triol. Thank you.
Good morning. I am Priyanka from BSc Chemistry Honors second year. Today my topic of presentation is carboxylic acid. First of all, what are carboxylic acid? Carboxylic acids are the organic compound which has COOH group in the alkyl chain. And then the types of classification of carboxylic acid are of three types. First way of classification is aliphatic and aromatic carboxylic acids. Aliphatic carboxylic acids are those carboxylic acids in which the COOH group is attached to the aliphatic carbon chain. For example, methanoic acid. And then aromatic carboxylic acids are those carboxylic acids in which the COOH group is attached to the benzene ring, that is benzoic acid. Then the second way of classification is benzenoid carboxylic acids and non-benzenoid carboxylic acids. Benzenoid carboxylic acids are those carboxylic acids in which the COH group is attached to the aliphatic carbon chain. मतलब उसके substituents या फिर principal chain किसी में भी benzene ring नहीं होनी चाहिए. Then non-benzenoid carboxylic acids are those carboxylic acids. Sorry. Second one is benzenoid carboxylic acid. These are those carboxylic acid in which the carboxylic acid is attached to the benzene ring either in the form of substituent or the principal carbon or in the principal carbon chain. Then the third way of classification is monocarboxylic acid and polycarboxylic acid. Monocarboxylic acid are those acids in which COH is present only in one, and polycarboxylic acids are those carboxylic acids in which there are two or more carboxylic acid group are present. Then I will explain blank rule. ब्लैंक रूल हमें बताता है कि जो कार्बोक्सिलिक एसिड है उसमें हम मतलब जिस टेम्परेचर पे हम उसको हीट करेंगे तो फिर क्या जो प्रोडक्ट है वो क्या बनेगा. तो फर्स्ट ऑफ ऑल 1,3 कार्बोक्सिलिक एसिड जो होते हैं उसको अगर हम 473 केल्विन टेम्परेचर पे हीट करेंगे तो वो CO2 लूज करेंगे और मोनोकार्बोक्सिलिक एसिड बना देंगे. Then 1,4 कार्बोक्सिलिक एसिड इसको हम जब 573 केल्विन टेम्परेचर पे हीट करेंगे तो ये H2O लूज करके मोनोहाइड 1,5 कार्बोक्सिलिक 1,6 एंड 1,7 कार्बोक्सिलिक एसिड इनको हम जब हीट करेंगे 573 केल्विन टेम्परेचर पे तो ये H2O एंड CO2 लूज करके साइक्लिक कीटोन्स बना लेंगे. 1,4 कार्बोक्सिलिक एसिड को जब हम 573 केल्विन टेम्परेचर पे हीट करेंगे तो ये H2O लूज करके एसिडिक एनहाइड्राइड बना लेंगे. Thank you.
Good morning. My name is Kriti. I am from BSc Chemistry Honors second year. My topic of presentation is spectroscopy. Spectroscopy, the branch of science which deals with the study of electromagnetic radiations with matter, is called spectroscopy. Spectroscopy is of two types: absorption spectroscopy and emission spectroscopy. Absorption spectroscopy is defined as the branch of science which deals with the study of the absorbed radiations from a continuous source that are utilized in raising the internal energy of a molecule, is known as absorption spectroscopy. And the spectra is known as absorption spectra. Emission spectroscopy. After the absorption of energy, the excited species return to the ground state as releasing the energy in the form of radiation. Emission spectroscopy. After the absorption of energy, the excited species return to the ground state. The absorbed energy in the form of the radiations is known as emission spectroscopy, and the spectra is known as emission spectra. Generally, the organic compounds work on the basis of absorption spectroscopy, and it does not work on the emission spectroscopy because the organic compound breaks under the conditions of emission spectroscopy. इस चैप्टर में हम यूवी विजिबल स्पेक्ट्रोस्कोपी के बारे में पढ़ेंगे और यूवी विजिबल स्पेक्ट्रोस्कोपी, the branch of science which deals with the study of UV visible radiations with matter, is known as UV visible spectroscopy. It deals with the measurement of energy absorbed when electrons transmitted from lower energy state to higher energy state. And UV visible spectroscopy is also known as electronic spectroscopy. Now the term is UV spectrum. UV spectrum is defined as plotting graph in between the wavelength of absorbed light and the absorbance. The lambda max is obtained by the maximum absorption takes place in the electronic transition is known as lambda max. UV spectrum is of three types: near or quartz UV, near or quartz spectrum, far UV और visible UV. Visible UV की रेंज
T से 780 नैनोमीटर तक होती है, और near or quartz UV 200 to 380 nanometer, and in the far UV 10 to 200 nanometer. The next term is Frank-Condon principle. In this principle, we will tell us about the time scale in the electronic excitation. Is 10 raised to the power minus 15 second is very much faster than the nuclear motion, which is 10 raised to the power minus 13 second. Law of adsorption, Beer's law, Lambert's law, and the combined form of Beer's-Lambert's law. Beer's law, it states that the fraction of absorption, it tells about the fraction of incident monochromatic light absorbed by the substance is directly proportional to the concentration of the substance. Lambert's law, it states that the fraction of incident monochromatic light absorbed by the substance is directly proportional to the number of molecules of the substance in the path length of the substance. The combined form Beer's-Lambert's law, it states that the fraction of incident monochromatic light absorbed by the substance is directly proportional to the concentration of the substance and the number of molecules of the substance in the path length. Thank you.
आ जाओ बेटा, नेक्स्ट आ जाओ।
Good morning, everyone. My name is Anu. I am from the chemistry second year, BSc Chemistry honors second year. My presentation topic is alcohol and their tests. Alcohol. What are alcohols? Alcohols are the organic compound which are formed by the replacement of one or more hydrogen atom from aliphatic or aromatic hydrocarbons. There are many tests to distinguish the primary, secondary, and tertiary alcohols. First test is Lucas test. What is Lucas test? Lucas test is the equimolar mixture of the concentrated HCl and anhydrous ZnCl2. When this test is treated with the primary alcohol, then the primary alcohol occurs no turbidity. And when the Lucas test treated with the secondary alcohol, then the turbidity occurs within 5 to 10 minutes. And when the Lucas test treated with the tertiary alcohol, then the turbidity occurs immediately, because in tertiary alcohols the carbocation formed is very stable, because tertiary carbocation is stable than the secondary and then the primary carbocation. And second test will be the Victor-Meyer test. In this test there are many color formed. When we treated primary alcohol with Pi3 means phosphorus triiodide, then OH group of primary alcohol replaced by iodine, and then this iodine compound reacted with AgNO2, then the iodine group is replaced by nitro group, and this nitro compound treated with HNO2 means nitrous acid, then the nitrolic acid formed, and when this nitrolic acid treated with the blue litmus paper, then the color of blue litmus paper turns into red. And when the secondary alcohols treated with Pi3, then the OH of secondary alcohol replaced by the iodine, and then iodo alcohol is treated with the AgNO2, then the iodine group is replaced by the NO2, and when this nitro compound is treated with HNO2, then the pseudonitrile formed, and when this treated with blue litmus paper, then there is no change in color and the solution remains same. When the tertiary alcohols are react with Pi3, the OH group of tertiary alcohol replaced by iodine, and then which is react with AgNO2, then iodine group of the iodine group replaced by NO2 group, and then when this nitro compound react with HNO2, there is no reaction because there is no hydrogen present. And the next test is oxidation. On oxidation, primary alcohol gives carboxylic acid, secondary alcohol gives ketones, and tertiary alcohols does not give any product because they have no hydrogen for oxidation. And there is one more which is Cu at 300 degrees Celsius reagent. When primary alcohol reacts with this reagent, aldehydes are formed, and secondary alcohols are react with this reagent, ketones are formed, and when tertiary alcohols are react with this reagent, there is no reaction of this. Thank you. Good morning to all. Today, my name is Sneha. I'm from BSc Chemistry on second year. Today, my presentation topic is UV spectroscopy. Firstly, we will discuss about spectroscopy, the branch of science which deals with the study of science with of interaction of which deals with the study of interaction of electromagnetic radiation with matter. There are two types of spectroscopy. First one is absorption spectroscopy, and second is emission spectroscopy. First one, absorption spectroscopy, the study of absorbed light that are utilized in raising of internal energy is called absorption spectroscopy, and the spectra is called absorption spectroscopy. The second one is emission spectroscopy. After the absorption of energy, there are the electronic spaces are returned to the ground state by emitting this absorption of light. The study of this emission is called emission spectroscopy, and the spectra is called emission spectroscopy. There are some modes of energy transfer from the source to the matter. First one is the energy transfer which requires medium, and second one is which requires no medium. Which requires medium is when it involves the movement of particles, that is named as conduction, and which involves with movement of particles is convection. After that, we will discuss about UV spectroscopy. UV spectroscopy is known as, it is the branch of chemistry which deals with the study of UV absorption with the interaction of UV absorption with matter is called UV absorption spectroscopy. It deals with the measurement of energy with the it deals with the measurement of energy when electrons are promoted from ground state to the higher energy state. UV spectroscopy is also known as electronic spectroscopy because UV spectroscopy involves the excitation and transmission of the electrons. There are some parts of UV spectrum, that is far spectra, near spectra, or U visible region. Far spectra it ranges from 10 nanometer to 200 nanometer. It is absorbed by the atmosphere because it's blessing to us because it will cause damage our cornea of eye. The second one is near spectra. It ranges from 200 nanometer to 380 nanometers. It is important because it is not absorbed by the atmosphere because it when electron excited in p orbital, d orbital, pi orbital, and particularly along with the conjugated pi system involves in this region. The third one is visible region, which ranges from 380 nanometer to 780 nanometers. After that, we have some law of absorption. There are three law of absorption, that is Beer's law, Lambert's law, and the combination of Beer's Lambert's law. Beer's law states that the fraction of the incident light by the substance is directly proportional to the concentration of molecules, and the Lambert's law is state that the fraction of incident light by the substance is directly proportional to the concentration of molecules, and the Beer's Lambert's law is the combination of Beer's law and the Lambert's law. That's all. Thank you.
Next slide.
Good morning to all of you. I am Mansi from BSc Chemistry Honors second year. Today I am giving presentation on topic alcohols and its classification. Alcohols. Alcohols are the organic compounds which are formed by the replacement of one or more H atoms from the aliphatic hydrocarbon or by the side chain of aromatic hydrocarbons by the hydroxyl group are called alcohols. For example, when we remove one H atom of methane and add OH atom, then we get methanol. Classification of alcohols. Alcohol can be classified in different ways. First way of classification is on the basis of hydrocarbon. These can be classified in two types: aromatic alcohol and aliphatic alcohols. Aliphatic alcohols, these are the alcohols which are formed by the replacement of one or more H atom from the aliphatic hydrocarbon chain by hydroxyl group. For example, methanol. Aromatic alcohols. Aromatic alcohols are the alcohols which are formed by the replacement of one or more H atom from the side chain of aromatic hydrocarbons. For example, benzyl alcohol. Second way of classification. The second way of classification is on the basis of number of OH groups present in the alcohols. These can be classified in three types: monohydric alcohol, dihydric alcohol, and trihydric alcohols. Monohydric alcohols. These are the alcohols in which contain only one OH group. For example, ethanol. Dihydric alcohol. These are the alcohols which contain two OH groups. For example, ethane 1,2-diol, which is known as ethylene glycol. Third one is trihydric alcohol, the alcohols which contain three OH group present in it. For example, propane 1,2,3-triol, that is glycerol. Monohydric alcohol is further of three types: primary alcohol, secondary alcohol, and tertiary alcohol. Primary alcohol, the alcohol in which the carbon containing OH group is further linked either with no carbon atom or one carbon atom. For example, ethanol. Secondary alcohol, the alcohols in which carbon containing OH group is further linked with two carbon atoms. For example, propane 2-ol. Tertiary alcohols, the alcohol in which the carbon containing OH group is further linked with three carbon atoms. For example, 2-methyl propane 2-ol. Thank you.
Okay, better next one.
Good morning, myself Madhu from BSc Chemistry Honors second year. Today's my presentation topic is alcohol and their test. First of all, what is alcohol? Alcohol is by replacement of one or more hydrogen atom from aromatic and aliphatic hydrocarbons. There are many type of tests from primary, secondary, and tertiary alcohols. First is Lucas test. What is Lucas test? Lucas tests are the mixture of concentrated HCl and anhydrous ZnCl2. When Lucas test is treated with primary alcohol, then it have no turbident alcohol. Then Lucas test is treated with secondary alcohol, then it has turbident in 5 to 10 minutes. Third, when Lucas test is treated by tertiary alcohol, then there is no product. Second test is Vector-Meyer test. In Vector-Meyer test, first of all, when PI3 is treated with primary alcohols, then OH group, when OH group is released in iodine. When the iodine is treated with AlCl2, then the nitrolyl group is present. Then the blue litmus paper is changed in red litmus paper. In secondary alcohol, when PI3 is treated, then the OH group is released and the iodine is formed. Then same as it is react with the AlCl2, it formed the nitric group, and the nitric group is treated with the HNO3. There is no any type of reaction show. And in tertiary alcohol, it is same as the when PI3 is treated, then the OH group is released and the iodine is formed. Then iodine is react with the AlCl2 and the nitric group is formed. It has no any type of reaction is formed. Third is oxidation. In oxidation, it is react with primary. There is carboxylic acid is formed, and secondary is treated. Then the ketones are formed. In the tertiary, there are no any reactions. Thank you.
Okay, better next one.
Good morning to all of you. My name is Tanu. I am the student of BSc Chemistry Honors second year. Today's my presentation topic is alcohol and their classifications. What are alcohols? Alcohols are the organic compounds which are formed by the replacement of the one or more hydrogen atom from from aromatic and one side chain of aromatic hydrogen compound. Classification of alcohol are different types. First, aromatic alcohol and aliphatic alcohol. Aliphatic alcohol, the alcohol in which formed by the hydrogen atom replacement of one hydrogen atom from aliphatic chain. The example of aliphatic alcohol is ethanol. Aromatic alcohol, the alcohol in which hydrogen atom replaced by the form of a side chain of aromatic alcohol. Second way of classification of alcohol is monohydric alcohol, trihydric alcohol.
Raju, better next. Not good.
Good morning. I am Hema from BSc Chemistry Honors Second Year. Today I am here to represent a presentation on a topic alcohols. Alcohols are the replacement of the hydrogen and alcohols are the replacement of the H atoms from the side chain of the aromatic hydrocarbons or from the aliphatic hydrocarbons by hydroxyl group. We can classify alcohols by two types. First type of classification is by aliphatic alcohols and second is aromatic alcohols. Aliphatic alcohols are those alcohols which we can determine by the replacement of one OH atom by the aliphatic hydrocarbons by hydroxyl group, and aromatic hydrocarbons are formed by the replacement of one or more OH atoms by the side chain of the aromatic hydrocarbons. And the example of aromatic hydrocarbons in benzyl alcohol. Second way of classification is by the types of alcohols. These are monohydric alcohol, dihydric alcohol, and trihydric alcohol. Monohydric alcohols are those which contain only one OH group. Dihydric alcohols are those which contain two OH groups, and trihydric alcohols are those which contain three OH groups. The examples of monohydric alcohol, dihydric alcohol, and trihydric alcohols are The example of monohydric alcohol is ethanol, in which only one OH group is attached. The example of dihydric alcohol is ethylene glycerol, in which two OH groups are attached. The example of trihydric alcohol is glycerol, in which two OH atoms are attached, three OH atoms. Further, monohydric alcohols are of three types: primary alcohols, secondary alcohols, and tertiary alcohols. Primary alcohols are those in which the carbon-containing OH group is further linked with one or no more carbon atoms. For example, ethanol. And secondary alcohols are those in which the carbon-containing OH group is further Secondary alcohols are those in which the carbon-containing OH group is further linked with two more OH atoms. For example, propane 2-ol. And the example of tertiary alcohols are those in which the carbon-containing OH group is further linked with three more aliphatic carbon containing three more OH groups. For example, 2-methyl-propyl 2-ol. Next, some physical properties of the alcohols are those: alcohols exist in liquid state, alcohols have high viscosity, alcohols have high boiling point, alcohols show molecular association, and the alcohols are acidic in nature mostly. Thank you.
Next, Raju.
Good morning, everyone. I am Bhavna from BSc Chemistry Honors second year. Today, my topic of presentation is alcohol and its classification. Firstly, should know what is alcohol. Alcohol are those species in which hydrogen atom are replaced from the aliphatic hydrocarbon or aromatic hydrocarbon by hydroxyl group. And alcohols are classified in two ways. Firstly, we study on the basis of hydrocarbons. Alcohols are classified in two ways. First is aliphatic hydrocarbons, aliphatic alcohols, and second is aromatic alcohols. Aliphatic alcohols are those in which one or more hydrogen atoms are replaced from aliphatic hydrocarbons by the hydroxyl group, that is OH. For example, ethanol is formed from the ethene, and second one is aromatic alcohol. Aromatic alcohol, those alcohol in which hydrogen atom replaced from the aromatic hydrocarbons by hydroxyl group. Second is classification on the basis of number of OH groups present. First is monohydric alcohol, dihydric alcohol, and trihydric alcohol. Monohydric alcohol are those in which only single OH group present, and dihydric alcohol are those in which two OH groups are present in the chain, and trihydric alcohol are those in which three OH groups present. And example of monohydric alcohol are ethanol, and dihydric alcohols are ethane 1,2-diol, and trihydric alcohol propane 1,2,3-triol. And second classification is and further, we classify monohydric alcohol in three ways, that is primary alcohol, secondary alcohol, and tertiary alcohol. Primary alcohol are those in which carbon containing functional group further linked with one carbon atom or no carbon atom. And secondary alcohol are those in which carbon containing functional group attached with two carbon atoms. For example, propane 2-ol, and tertiary alcohol are those in which carbon containing functional group are attached to more than two carbon atoms. For example, 2-methyl propane 2-ol. Thank you.
Next, Raju.
Hello everyone, myself Bhartiya from BSc second year chemistry honors. Today's my topic is alcohol of presentation. Alcohol is considered as a hydroxy group from aliphatic